Welcome to the VXD Preaction System Double-Interlock Electric Pneu-Lectric Release Simulation Scenario. We're going to cover what happens when a fire starts in an environment that is protected by a VXD Preaction System equipped with a Double-Interlock Electric Pneu-Electric Release, and what each component of the system does to ensure the fire becomes controlled as quickly as possible.
The VXD deluge valve is a flood valve with only one moving mechanism. The valve is held closed by priming water pressure trapped in the priming chamber. This keeps the outlet chamber and system piping empty. The prime line directs water to the prime chamber of the deluge valve. The prime line consists of an open priming ball valve, a Y strainer, a restricted orifice, and a check valve. The Y strainer keeps debris from entering the restricted orifice. The restricted orifice reduces the rate at which water can enter the prime chamber, ensuring the prime water will drain faster than it can be supplied. The check valve only permits water to enter the priming chamber, allowing prime chamber pressure to be maintained. Following the trim off the prime chamber is the pressure-operated relief valve, or PORV. The PORV is a device that ensures the valve remains in an open state while water is flowing through the valve. When water is directed to the sensing side of the PORV, the push rod is forced open. Priming water is then directed to the open drain, preventing the priming chamber from repressurizing. The normally closed electric solenoid valve is attached to the top of the prime line. While closed, the solenoid valve keeps water pressure in the prime chamber. When activated open, it releases water pressure from the prime chamber.
The EA-1 is a microprocessor-equipped quick opening device. By monitoring the air pressure in half-second increments, the EA-1 can detect an activated sprinkler and trip the system within 4 seconds, making it faster than other quick opening devices in a variety of system designs. Since it's an electric detector, it's resistant to false activations and interference from debris and the water supply, making it more consistent when compared to mechanical accelerators.
The electric detection method in this scenario is linear heat detecting wire. In a scenario where a fire has started and begins to grow, the linear heat detecting wire will melt, causing a short that is detected by the VFR 500 release control panel's first detection zone. Since this is a double interlock system, the system will not activate until the second interlock is completed.
As the heat builds and the sprinkler activates, the air pressure in the sprinkler piping suddenly drops, causing the EA-1 to activate within 4 seconds and send a signal to the VFR 500 release control panel. This signal is the second interlock the panel is waiting for.
Once the signal is received, the VFR 500 sends 24 volts of electricity to the normally closed electric solenoid valve and powers it open, releasing water pressure from within the priming chamber of the deluge valve. Once water pressure is released from the priming chamber, the clapper is forced open by the supply water pressure from the inlet chamber, filling the valve body and connected trim with water. The PORV is activated when water from the main supply forces the push rod open, redirecting prime water out into the drain. Simultaneously, water will also fill the trim leading to the water flow alarm, causing it to activate, alerting the VFR 500 release control panel.
Water fills the system piping and is discharged through any open sprinklers, controlling the fire.
The valve continues to supply water to the system until it is shut down.